Okay guys, so what's the solution to this problem?
Peace.
Very good.
What does this world come to? Blatantly incorrect physics riddles our youth.
Your coach got ran over 15 times. There's nothing left.
I have to win this fight for my coach. You're a monster.
Master, where am I? We're inside of your mind. I must teach you the move.
I thought you swore to never teach that to another student.
That's alright, son. I ain't seen a move like that since now.
Why have you come?
I can't beat him. I can't beat Dave.
Mr. Willard, my boy, you have so much energy. If you would just channel it in the right way, you'd be a master of classical physics.
But I just lost so badly, and I've killed my last 6 coaches. Who's gonna train me now?
I will.
Who even are you?
My name is Roger Penrose. I worked along Einstein, Heisenberg, Hawking, and outlasted them all. I predicted black holes, I solved equations Einstein couldn't, I created spin networks, and I can teach you if you're willing to change your ways.
Of course. I'll follow the teachings of classical physics to the very end if you help me.
It's Dave! Dave, my son, come forward. Your potential energy is a level I have not witnessed in decades. There are powers that you could harness that no one on this earth has ever harnessed. That is, if you truly want a challenge from physics.
I don't know if I'm ready for a new coach yet. And how do you know my name? Who are you anyway?
My boy, I'm Edward Witten. I've worked in the dark arts of quantum physics and string theory longer than you've been alive. You may not know who I am or what those fields are, but the world will come to know you and your power if you follow the Feynman path.
Yes, this is it. I've always wanted to achieve ultimate understanding, but it always felt like there was something missing. This must be it. I'll do whatever it takes, Master.
Good. This is the way to free will, discrete space-time, and becoming a god among men. But once you go down the dark path of quantum mechanics, there is no going back. Come, boy. We have training to do. The wave function collapse, also known as decoherence, is a process by which a probabilistic wave turns into a deterministic particle. There is no consensus on what the process really is, but there are theories. The first one is the Copenhagen interpretation, which states that a human observer causes the wave to collapse to a particle. Some new research provides evidence that any interaction with something outside the quantum realm will cause it to decohere, however, not just human observation. Another popular theory is the many worlds interpretation, which says that all possibilities along the wave function take place just in different universes, and we only observe one possibility. This means that the universe is constantly splitting, and every possible version of your life is happening somewhere in the multiverse. There are also more obscure theories that go even deeper, such as the one my arch nemesis Roger Penrose proposed. He says that gravity causes the wave function to collapse once there is too much of an energy difference between possible states along the wave. His ideas are vile, though.
I can't let you take down the Physics Council.
Too bad. I'm already greater than the Physics Council.
The difference in our potential is so large, there's gonna be a voltage jump.
I'm gonna use a photoelectric effect to disassemble your molecular structure.
Really, let's see if your face has the capacitance for these fists.
I'm gonna punch you so hard your remains are gonna be a diffraction grating on that wall. You thought you could beat me with your Newtonian mechanics? That's not how the quantum realm works. We don't obey by Newton's laws.
My physics is more powerful than you can ever imagine.
It's over, Whitney.
I'll see you soon, Penrose.
My apprentice, I have a mission for you to complete. I need you to study some new abilities at my old lair before you pay a visit to the Physics High Council.
It will be done, my lord.
This is not the physics I taught you, and this is not the honorable man I trained.
I'm sorry, Coach, but I don't need you anymore. My powers have surpassed anything that I ever believed was possible, and I was learning from you.
I said I would never teach that move to another student for a reason, but I was desperate, and now I failed you. Dave, I have failed you.
You only failed to keep me and my power suppressed. Now I know how you keep coming back. You are in a superposition of dead and alive. Let me simplify things for you. I have some work to do. Thank you for seeing me, Masters. I promise that this will be worth your valuable time. There's a traitor in our midst. Mr. Willard plans to undermine your rule and disrupt our studies of physics. I know that may come as a surprise to you, but just remember how vicious he was while in the boxing ring. Regardless, I come with a solution. Watch. I've made some breakthroughs, all to help you take on that traitor Willard, of course, but only if you will allow me to guide the council. Otherwise, I'll just let him have at you.
With these powers, you must lead us.
From this moment forward, Willard is expelled from the Physics Council, and our new leader is the almighty Dave.
Willard, I don't know how they found you here. I'm the only one that knows you're with me.
This letter's from the Physics Council. It says they've kicked me out because Dave showed them true physics. What does this all mean? How?
It means we have to fight back.
What?
I don't know if I should tell you this, as I've only heard rumors, but an old foe of mine, Edward Witten, has recently returned from exile, and he may have turned Dave to the quantum realm. If this is true, our whole universe is in danger.
I've only heard whispers about quantum physics. I didn't know it was real. And how can that Dave guy be a threat to the universe? I mean, he was a decent boxer, but not that good.
I don't know much about the quantum realm, as tampering because it terrifies me, but I do know one thing.
There are many quantum fields permeating our universe, which each generate the different particles and force particles that make up reality. Most of these fields have a net energy of 0, but because the quantum uncertainty, particles still arise as fields fluctuate in energy levels. Particles are the manifestation of changes in energy levels within these quantum fields. The only one of these quantum fields that has a vacuum energy expected value greater than 0 is the Higgs field. But because values are unstable like the rest of the quantum fields, any abnormal quantum fluctuation could cause it to fall into the new lowest energy state, like all the other fields. The Higgs field's net energies is what causes particles that we are made of to have mass, since mass and energy are equivalent. The Higgs field's particle, the Higgs boson, interacts with most particles that gives energy and therefore mass in the encounter. Without the Higgs field, all the fields would just pop out of existence as nothing but quantum randomness. The Higgs field gives particles a level of permeance. So if the Higgs field mechanism changes, the universe will cease to exist the way we know it, and there may be no mass left at all.
May Galileo save us all.
No, Mr. Willard, it must be you. I've passed on all my knowledge to you, despite my years.
I know what I must do.
What can you tell me about string theory, Master?
No, you foolish child. That's too dangerous. Those are secrets I would never reveal.
Then you have outlived your use for me.
I already know where Dave's base is, and we're going to attack him before he gets too powerful.
Dave's physics is non-local. He will know your plan before you even make the move.
It doesn't matter. The fate of the universe is on the line. This is the fight of our lives. We don't have to fight, Dave, but I will do what I must.
You will try.
Dave has maximized his power. He's using a physics beyond physics. He learned how to switch between a probabilistic wave and a deterministic particle. This allows him to quantum tunnel. Quantum tunneling is a phenomenon in which fundamental particles, such as electrons, can go through potential energy barriers that they would normally have to steadily climb over if we were dealing with classical mechanics. Think of it like a car teleporting through a hill instead of going up and over it. This is possible at the quantum level because of the probabilistic nature of matter particles and specifically the Heisenberg uncertainty principle. This states that you cannot precisely know both the location and momentum of a particle. The more you know about one, the less you know about the other. The effect of this fact is that particles such as electrons and photons have positions that are always in flux and can appear to teleport across energy levels. I fear Dave is too far gone down the quantum path. He must be stopped.
What have you done?
Something I wanted to avoid.
We are now in a state of quantum entanglement. Whenever two fundamental particles are generated from an interaction, such as a pair of photons, some properties of them are innately random due to the nature of quantum mechanics. As we know, interacting with one of the photons causes the wave function to collapse, and definitive properties of the particle can be observed. Now, with quantum entanglement, the observation of one of the photons causes the other to instantaneously collapse too, even if it would require the particles to share information faster than the speed of light, which is known as the EPR paradox. Since faster-than-light travel is impossible, entangled particles being connected to each other without directly interacting is known as non-locality, and was actually only recently proven experimentally in 2022. Quantum entanglement means that particles can share a connection from their generation that extends to when they are vast distances apart, and interacting with one means interacting with the other. Electron-positron pairs, neutrino-antineutrino pairs, and more can exhibit this behavior, and properties such as position, momentum, and spin can be determined with it. Einstein called this phenomenon spooky action at a distance, and it is one of the things that makes quantum physics fundamentally different from classical physics. It doesn't matter if we are entangled or not, I'm going to eliminate you.
Now that we're entangled, you'll never be able to escape. Even if you're 100 light years away, I will have instantaneous access to all of your information and all of your movements.
I can never be killed, fool. I have achieved quantum immortality. Whenever a wave function collapses, all possibilities still take place, just in different universes, splitting infinitely. My consciousness will live on in a different part of the universe no matter what happens.
You may think that, but there's no part of the superposition in which you survive this. I know the probability of your survival is 0 by using the finite path integral. There are a variety of ways to describe the wave function that is at the foundation of quantum mechanics. One of these ways is Richard Feynman's path integral formulation. As the name suggests, it is a mathematical approach to adding up all the possible paths a particle can take in order to determine the probabilities of it reaching different end states. This formulation is driven by 2 key principles. First, that a quantum particle takes no well-defined trajectory between 2 points at which it is observed. This led to Feynman's insight that the transition probability amplitude between points can be found by integrating all the possible routes. Second, the contribution to the amplitude from any given path has a corresponding classical action along said path. With that classical element, possible particle paths can be described in a manner that allows for integration. The probability for any given outcome ends up being the square of a complex number known as the probability amplitude. As previously stated, the probability amplitude comes from integrating the contributions of all possible paths within the path integral. Each contribution from each possible path is proportional to the value e to the is divided by the reduced Planck's constant, where s is the action obtained from a Lagrangian describing classical particle motion. Action is a changing of the balance of kinetic and potential energy and is measured in joules per second by integrating the difference between kinetic and potential energy with respect to time. The dx simply indicates the domain of the paths, while the 1 over z outside the integrand is just a normalization constant. When you finally sum all these path contributions, you get a clear amplitude because the more outrageous paths interfere with each other mathematically through the complex element, just as we observe experimentally. This approach has been proven equivalent to descriptions such as the Schrödinger equation, though each is useful for different situations. A way to think about the path integral technique intuitively is to recall the double slit experiment. But now imagine you have many slits cut into an infinitely long barrier, and the slits are infinitesimally close together. Now take many copies of that barrier and stack them infinitesimally close to each other between the emitter and the detector. We end up with empty space. However, all our principles still apply. A particle passes through all the slits of the first barrier, second barrier, and so on, but with differing probabilities each time depending on how long the path is. The particle, behaving as a wave, travels through every path until it is collapsed and we observe a final position. This is the Feynman path integral.
Ramus Willard was then able to maintain an insulated quantum state. This way, he could teach classical physics, minus vertical spring and one-slit wave problems, of course, to the rest of the world. And as long as he's never observed, he can never collapse. That's why us as students can't pay attention in class, because if we look at him too hard, he might just disappear.